All right, it's been a little while. Hope everyone enjoyed the mini break. Let's go ahead and get to work. Today is just kind of an extension of the previous lesson. So be sure you have your notes page kind of out to the side of you as we take these notes. Got 5 examples. Some will go a little quicker than others. Let's go ahead and get started. Here for number 1, and by the way, for all these, we're just trying to keep one side the same. So if I decide to work with the left side, which that's what I'm going to do because it's way complicated and I can't really do much with one, then that means my right side needs to stay as 1 the entire time. Okay? So let's go and get started. So I get secant squared x can actually be pulled out of both of these pieces. So I got secant squared x times, and then parentheses 1 minus sine squared x. Okay, and then secant squared x still there. 1 minus sine squared x, if you look on your formula chart there down at the bottom, you see that sine squared x plus cosine squared x equals 1. So if I were to move, here I'll write this down. If I were to move this over here, sine squared x over there, I would get cosine squared x. So 1 minus sine squared x is cosine squared x. So secant squared is 1 over cosine squared x. Cosine squared x is just cosine squared x over 1. So therefore 1 equals 1. Ta-da! Okay? It's important to know those Pythagorean identities. On number 2, I can't really do much of the left-hand side, but the right-hand side, I can actually factor that. Hold on one sec.
Good afternoon, students. It is 4:20. Please make sure that you have been assigned to a designated area for tutoring or making up lots of credit hours. Please make sure that you are going to a designated area. If not, it is time for you to please leave campus, especially those students who are down by the gym. If you are not in a designated area, you are not assigned to an individual teacher, you need to leave campus at this time. Thank you.
Okay, cool. So what I've written down here is I factored that. And then this part is kind of the same idea. X to the 4th minus 16 is x squared plus 4, x squared minus 4. So using that same logic, we can factor that right there. Okay. So I got 1 plus 2 tangent squared x on the left-hand side. Left-hand side is not changing at all. It's important that we always keep that. And when we get stuck, we need to start over. Don't just start changing stuff all willy-nilly. On your formula chart, down there at the bottom area, you should have some sort of secant squared equals tangent squared, all that stuff. Well, what you're going to eventually find out is that 1 is secant squared x minus tangent squared x. On your paper, you might have like secant is 1 minus tangent, or 1 plus tangent squared, or something like that. But anyway, secant squared x minus tangent squared x, that's what we have written right there. So that means this is 1. And I got secant squared x plus tangent squared x. Well, no matter what manipulation I do with this, I can't get it to be secant squared x plus tangent squared x. So we're going to have to do a little other manipulation. So left side stays the same. And then my right side is secant squared x plus tangent squared x. Well, from this same idea, if I were to manipulate secant squared x, if I were to get this by itself, I'd move tangent squared back over. So then secant squared x would be 1 plus tangent squared x. So we look there. I got 2 tangent squared x's. So 1 plus 2 tangent squared x equals 1 plus 2 tangent squared x. Ta-da! That was a little more tricky. Number 3, have the kids do it by themselves. Number 3 is not that bad. So cosecant is the same thing as 1 over sine, so times cosine squared x plus sine x equals cosecant. As you can see, I'm already starting to change the left-hand side around a little bit. So we multiply that. And the last thing to do is find a common denominator. Well, with this, our common denominator is going to be sine. So if I multiply the bottom, I got to multiply the top, which is going to be sine squared. So then lastly, cosine squared x plus sine squared x. We can do that now that we have a common denominator. This whole thing is 1. 1 over sine x is equal to cosecant of x, which is cosecant of x. Boom. Number four we struggle with a little bit just because you got to use something called conjugate, and we don't really remember what that is. Conjugate is kind of like the opposite sign of the denominator here. So 1 minus cosine x, 1 minus cosine x. So left side stays the same. Distribute that, so I get sine x minus sine x cosine x over 1 minus cosine squared x. Well, this whole thing, denominator, is sine squared x. And that's from our Pythagorean identities. So then I get sine x minus sine x cosine x. Sorry, I'm going to change colors. My bad. And then kind of our last step before we get the answer is to rewrite this as sine x over sine squared x minus sine x cosine x over sine squared x. And as you can see there, if I got one sign on top, one sign, or two signs on bottom, one would cancel out. So I got 1 over sine, which is cosecant of x, which is what we have over here. And then one would cancel out, one would cancel out there. So I got cosine over sine, which is cotangent of x. And what do you look at that? It matches. And then the last one, numero cinco. This one is way easier than it looks. Maybe it doesn't look that easy, but sine, I don't know if you can see that or not. I'll go with orange. Cool. Sine x, cosecant is 1 over sine x plus cosine x, 1 over cosine x equals 1. Well, when you flip this and multiply, you get sine squared x plus cosine squared x, which is 1. So 1 equals 1. Boom. See you later.